the hypotenuse in a case like this is always whatever that x value is multiplied by root 2. So those ratios are always the same. So underneath the 45, 45, 90, maybe you want to write x, x, and x root 2. Not that you're going to have to memorize that, but these values are where these values are going to come from when we fill this in, and you do have to memorize this. So if you ever do forget how this works, you could always go back to your special right triangles. Now in a 30, 60, 90, the smallest side is x. By the way, that's always the smallest side in the 45, 45, 90 as well, right? How do we know this is smaller than this? In a right triangle, what's always the longest side? Hypotenuse. So this has to be smallest, right? Here, the 30-degree side angle, the shortest side is across from it. Do you remember that property from geometry? Smallest angle, go across from it, you get the smallest side. Biggest angle, you go across from it, you get the biggest side. And then the middle angle gives you the middle side. So the smallest side is always x. In this one, the hypotenuse is just always double that, 2x. And the middle side is always that x times root 3. So if I'm lining it up, this would be x, x root 3, and 2x. So just to talk more quickly, I call this the 30-degree side. That's because it's across from the 30-degree angle. This I will refer to as the 60-degree side because it's across from the 60. And obviously then the hypotenuse is the hypotenuse. Okie doke? So, in order to kind of get here, we have to review SOHCAHTOA. Okay? And say that very phonetically. So that you know it's an O and an H. What does that stand for? Opposite over hypotenuse. So the sine of an angle is always equivalent to the opposite side over the hypotenuse side. When you say ka, very phonetically, remind yourself that that's an A. The cosine of an angle is always equal to, what's the A stand for? Adjacent over hypotenuse. And then the tangent of an angle, so the tangent of theta, is always equal to TOA. What does the O stand for? Opposite over adjacent. You remember that? Okay. I guess I just realized I never actually fully ever write out its sine, spelled S-I-N-E. Sin is like just the abbreviation for it on your calculator. Cosine is C-O-S-I-N-E. And tan is abbreviated for tangent, which that's not the first time you've seen that word at all because you did tangents to circles last year, right? Okay, so if we look at the 30-degree angle, which is here, and we're looking for the sine of it, the opposite is x, yes? So let's just do randomly the sine of 30, just as a practice. Sine of 30. The opposite is x, and the hypotenuse is 2x. So what does that reduce to when you simplify? 1 over 2. Your x's cancel, 1/2. The sine of 30 is 1/2. Always will be. Okay? Let's do the cosine of another random one. Let's do the cosine of 45. The 45 angles here. Cosine is adjacent. What's the adjacent side here? Andrew? Why not the x root 2? Right, because that's the hypotenuse, and the hypotenuse trumps everything. So any angle technically has two adjacent sides. Adjacent just means next to. It's got an adjacent side x and an adjacent side x root 2. So if you're deciding which adjacent one to choose, you always choose the one that's not the hypotenuse because this is always trumped by the hypotenuse. So your adjacent to 45 is x over your hypotenuse, x root 2. Now your x's here cancel as well, correct? So it's 1 over root 2. But we can't leave radicals in the denominator. So we rationalize. What do I multiply by over itself to rationalize this? Taking us back. You multiply by 1, but you have to multiply by 1 creatively so that you're changing the appearance but not the value. Anybody? Nathan? Root 2 over root 2, correct. So my numerator is just root 2. And on my denominator, root 2 times root 2 is just the whole number 2. So this rationalizes to root 2 over root 2. I'm sorry, root 2 over 2. And then we'll just do the tangent of, let's say, a 60-degree angle. So here's my 60-degree angle in the diagram. Tangent is opposite. Aiden, what's the opposite side of the 60-degree angle? And what's the adjacent? X, very good. Pick the right adjacent because we don't want to pick the hypotenuse. And then so with that, your x is just canceling. We just have square root 3. Now, the zeros and the 90s, it's a little bit harder to do with the, well, it's harder to envision with the triangles because if you have a 0-degree angle in a triangle, you don't have a triangle, right? And in the 90-degree one, you can't really use SOHCAHTOA for that either because the opposite and the hypotenuse would be the same thing, and so you can't really use SOHCAHTOA with that either. So we'll fill in the rest of that, and I'll tell you that you're going to have to memorize it a little bit later on. But in general, the sine of any angle, what do you know about the length of an opposite side versus a hypotenuse always? Which one's always going to be bigger? The hypotenuse. So if you have a smaller number over a bigger number, can it ever be greater than 1? No. A smaller number over a bigger number always has to be less than or equal to 1. Technically less than 1, but you'll see in the 0 and in the 90 case, we actually hit 1. And even though these are side lengths, for the first time, you're going to be able to think of side lengths as being negative. So the lowest this would ever get is -1, and we'll see some examples of that as well. In cosine, we have the same thing. Isn't the adjacent side always going to be smaller than the hypotenuse? So that's also always between -1 and 1. The tangent can go a whole bunch of directions, right? The opposite side could be bigger or smaller than the adjacent side. So this one, there's no limitations. It can be -infinity to infinity. Okay, so there's some background here. And so we're going to be using SOHCAHTOA quite a bit today and keeping these things in mind just to check ourselves. So here's a typical example. In trig, you're going to be given points a lot. Plot the point. Always plot the point. So here, if a point 3, 4, plot 3, 4, what quadrant are we in? First. Good. Here's the other thing you always do in trig when you plot a point that they give you. Draw a terminal ray to that point. That terminal ray, you'll see in a second, is always going to act as the hypotenuse of a right triangle. You're always going to drop an altitude to your x-axis. So drop an altitude to your x-axis to create that right triangle. So always draw altitude to the x-axis, never the y. Kind of like we do with a reference angle, always to the x-axis, never the y. And so by giving us this point 3, 4, what can you tell me about the length of this leg? How about Cameron? How long is this?
Is it
3, right? To get to 3, 4, we came out 3 units, so that's 3. And to get up, we went up 4 units, right? So by giving you the point, you will always know 2 legs of the right triangle. How do you always find the third? Pythagorean theorem. So 3 squared plus 4 squared equals hypotenuse squared. 9 plus 16 is 25 equals h squared. So what is the length of your hypotenuse? 5. Yes? Now, hypotenuses, you're going to find out, still always have to be positive. So the hypotenuse always has to be positive. That's not going to be true for your legs anymore in trig. We'll get there in a second. So now let's even read how about we start by reading then read the question, right? You're going to do all this probably before you even read the question, because everything in trig is going to boil down to right triangles, Pythagorean theorem, and SOHCAHTOA. So here we have our angle theta. Find the values. Oh, by the way, how do I know that's theta? Why isn't this one theta? Theta is always the angle that's made at the origin. Okay? So theta will always be the angle at the origin when you draw these triangles. So what is the value of the sine of theta? Sine is what over what in terms of SOHCAHTOA? So what is the opposite? 4. And what is the hypotenuse? 5. There you go. There's your value of the sine of theta. What is the value of the cosine of theta? Kaylee Smith. 3 over 5. Adjacent of that angle is the 3, and hypotenuse is 5. And lastly, what is the tangent of that angle? How about John?
The opposite is 4.
Over.
And then adjacent 3.
Very good. Can we confirm that 4/5 is between -1 and 1? It's 0.8. Cosine 3/5 is between -1 and 1, 0.6. This particular tangent value is 1.33333, which doesn't matter because tangent can be anything. Got it? Okie doke. All right, let's switch how they're giving us this. The tangent, ooh, I don't know if we're ready for this. Oh, maybe we are. The tangent of some angle is -2/3. So this is the opposite. That's the -2. And the 3 is the adjacent, right? You're not real. I got to make myself a note next year to flip around the order of this. I'm going to tell you that this is in quadrant 4. You're going to be able to figure that out on your own in a minute. But this angle is in quadrant 4. So I'm going to draw a terminal ray to quadrant 4. I'm going to drop an altitude to my x-axis. Here's my theta, right? Theta is always the angle with the origin. And they're telling me that the tangent is opposite over adjacent, is -2/3. So my opposite side is -2. This is where I'm telling you you're going to start being able to label legs with negative numbers. And your adjacent side here is 3. Doesn't that make sense from a coordinate standpoint? Because to get to this point, I would go over 3, that's a positive 3, right? And down 2. So the other way they could give me this same diagram would be by telling me that the point 3, -2, like kind of like this one did, they'll give you the point instead. So sometimes they'll give you the point, and sometimes they'll give you this information. Okay? Find the values now of sine and cosine. So I have to find my hypotenuse. What's -2 squared plus 3 squared equals h squared? That's 4 plus 9 is what? 13 equals h squared. So what is h? Not as a decimal, as a radical. Radical 13, always positive. You don't need the plus or minus there because you're solving for the hypotenuse. Sometimes we will need the plus or minus, and we'll have to decide which it is based on what quadrant we're in. So now, pretty straightforward. Grace, what's the sign of theta? Perfect. Except for, what don't we like about that? Right, so we would rationalize by multiplying by root 13 over root 13, and we get negative 2 root 13 over 13. Cosine of theta is going to be what, Connor? 3 over radical 13. We'll rationalize that, and it will be 3 root 13 over 13. Cosine is adjacent over hypotenuse. Okie doke? All right. So here's a little phrase I'm going to tell you. Going around the quadrants, all students take calculus. Okay, remember that. All students take calculus. Here's what it tells you. In the first quadrant, this is always what? Positive or negative? Positive. What is this? Positive, and our hypotenuse is always positive. So no matter what you're doing, sine, cosine, or tangent, positive over positive, or positive over positive, or positive over positive is always positive. Sine, cosine, and tangent are all positive there. Okay? If you go to the second quadrant, though, only sine is positive. And here's why. If you go left, is this positive or negative? Negative. If you go up, is this positive or negative? Positive. And this is always positive because it's hypotenuse. So the cosine, which is adjacent over hypotenuse, would be a negative over a positive. The cosine is negative. The tangent, which is opposite over adjacent, positive over negative, is also a negative. The only thing that remains positive is S for sine, because the opposite is still positive over the hypotenuse is still positive. Do you follow? Okay? So only sine is positive there. If I do something in the third quadrant, only tangent is going to be positive. Here's why. This is a negative coordinate because I'm going left. This is a negative coordinate because I'm going down. And this hypotenuses are always positive. So if I do the tangent of this angle, the opposite is negative over the adjacent is negative, and a double negative is a positive. So tangent remains positive. But if you look at sine and cosine down here, they're going to still be negative because one is negative over positive for the opposite over hypotenuse, and the other one is negative over positive for the adjacent over hypotenuse. Do you follow? And in the last quadrant, only cosine is positive because there's a positive leg. This is a negative leg because I'm going down if I'm talking coordinates, and this is positive. So why is cosine positive? Because adjacent is positive over hypotenuse is positive. So it stays positive. But sine is going to involve this opposite negative side. And tangent is going to involve this opposite negative side. So those both are negative. So all students take calculus is what we're going to use to tell us what is positive and where. So if I go back to this example now, and you can just watch up here, I knew tangent was negative. So it couldn't be in this quadrant because tangent's positive there, and it couldn't be in this quadrant because tangent is positive there. So I knew just by the fact that tangent was negative that it had to be here or here. And then because cosine was positive, greater than 0, I knew it was in the fourth quadrant. Do you follow? Okay? So this section is just asking us, what quadrant are we in? Okay? If sine is negative, we can't be here, right? And we can't be here. So we're limited to here or here. Cosine is greater than 0, so cosine is positive. So you tell me, is it quadrant 3 or quadrant 4? 4. Let's try that again with a second example. Sine is positive. It's greater than 0. So Cameron, which two quadrants does that make us boil this down to if sine is positive? Blank or blank? Second or first? All are positive in the first, right? So first or second. Now, to narrow it down further, tangent is negative. So it has to be the second. Does this make sense? In this next one, tangent is positive, so which two quadrants does that boil it down to, Kaylee M, if tangent is positive? Say it again? Okay, so first or third. And then to boil it down further, if cosine is less than 0, Aiden, which one is it? First or third?
Third.
Third, perfect. We get that now? Okay, let's jump to the last one. Find the exact value of each of the remaining trig functions. So they're giving us sine. Okay, and they're telling us theta's in the third quadrant. Well, because sine was negative, I knew it was 3 or 4 anyway. They just told me it's in the third quadrant. So let's draw it. A terminal ray in the third quadrant. Make your right triangle. My theta is always this one towards the origin. Which sides can I label and how? Help me out there. Go ahead, Bo, give it a stab.
Is 13 the opposite?
Nope.
I mean, the adjacent?
Nope. Hold on. This is right now.
Or no?
Yes, thank you. Lydia, you have to go to Mrs. Batten at the end of the period, okay? Sine is, and put this in there, opposite over hypotenuse. So the hypotenuse is 13, right? Never negative. The negative sign, therefore, must be going with the numerator, which is the opposite, which is here, negative 12. That makes sense because it's going down, yes? So we would do the Pythagorean theorem. So what squared plus negative 12 squared equals 13 squared? So this is 144, and this is 169. If you subtract your 144 over, you get 25. Now, I'm solving for a leg here. So when I take the square root of both sides, it's either plus or minus 5. Because legs can be plus or minus. Hypotenuses can't. Which is it based on the fact that we're going left? Negative 5. Excellent. Okay, so now to come up with the other two trig functions, it says the remaining, we were given the sign. Cosine is what over what? Adjacent over hypotenuse, so what's the adjacent? Negative 5 over the hypotenuse, 13. And the tangent is opposite over adjacent, TOA, right? TOA, opposite over adjacent, what's the opposite? Negative 12, what's the adjacent? Negative 5, and this can be reduced in that what? A double negative is a positive, so just 12/5. Doesn't that make sense? Remember, all students take calculus, only tangent is supposed to be positive here. And look, it is. Positive. Cosine's negative, sine is negative. Okay? When they tell you this, what quadrant are you in? Q4. Right? The angles between 270, those should have degrees symbol. That's naughty of me. And then in the last one, take a minute, think about what quadrant we're in, and then all of these will be the same as far as drawing the triangle. Think about what quadrant we are in. And then I'm going to say on the count of 3 to hold up 1, 2, 3, or 4. So think about it. I got to think about it. Are you ready? Hold up 1, 2, 3, or 4. On your mark, get set, go. To the second quadrant. Look it. tangent is negative. So it can't be there and it can't be there. Because those are where tangent's positive. So since tangent is negative, it's here or here. Sine is positive. Greater than 0 means positive, right? So that's out. Sine is positive there. Second quadrant, right? That takes some legwork. And then once that happens, you can draw your triangles. Andy, did you get one of these? Okay, your homework problems, obviously the worksheet looks a little different. This should be done on a separate sheet of paper. Oh, that reminds me, I keep forgetting to tell you. I'm over the separate sheet of paper thing on our typical assignments because they're giving you enough space to show your work, right? But on this is copied out of a textbook. There is no space to show your work. So this, you do need a separate sheet of paper, okay? But moving forward, if you don't want to use a separate sheet of paper, if there's enough room, go for it. But I'll be specific. This one needs to be a separate sheet of paper. That one.